Hello everyone. Today we'll do the applications of potentiometer. The first one is to compare EMFs of two cells. So we'll draw the figure. This is how the potentiometer looks like. It has four wires connected on a wooden board like this. We'll connect two cells. This is one with EMF E1. Let this be point 1. We'll connect the other cell. Connect the other cell 2 with EMF E2. Let this be point 2. Here we have point 3 that is connected to a galvanometer and point somewhere here. We don't know. We also have a scale to measure the length. Now we'll connect the battery and the rheostat. We'll connect the ammeter. This is how our figure looks like. So the first step that we have is we'll connect points 1 and 3 like this and then obtain the balance point. That is when the galvanometer shows zero deflection. So let the length be L1. So E1 is directly proportional to L1. Second one is connect 2 and 3. Now we'll remove 1 and 3 and we'll connect 2 and 3 to each other. Same steps, balance point, we'll obtain the balance point and we'll let the balance point to be L2. So E1, E2 is directly proportional to L2. Therefore, we get E1 by E2 is equal to L1 by L2. This is how we compare the EMFs of two cells. So we'll continue with our next application, that is to find the internal R of a cell. We'll make the similar figure that we made before. We'll construct the potentiometer quickly. On a wooden board, these wires are laid out like this. We have the scale here. That scale. We'll connect a cell. This is G. The galvanometer, it will point somewhere here. We don't know where. The cell EMF is E and the internal resistance is R. We also connect a resistance R and a key here to the galvanometer. Resistance R. We connect the rheostat and the battery. We have the battery, we have the rheostat, we have the ammeter here, and it points towards this minus plus. So as we did before, we'll obtain balance points. So in the first step, we obtain the balance point with respect to E. Obtain the balance point when the galvanometer shows deflection 300 and we let the length to be L. So E is directly proportional to L. Next, what we'll do is now we plug in the key. Now R is added to the circuit. R is introduced. We plug in the key here. We'll obtain the length by taking the balance point. Obtain the length. Let it be L2. So V is directly proportional to L2. So now we know E1 E by V is equals to L1 by L2 according to the previous derivation that we did. As we also know that R is equal to E by V minus 1 into capital R. So equating this in this equation, we'll consider these two equations. We get R is equals to L1 by L2 minus 1. This is how we find the internal resistance of a cell using potential. Thank you, and I'll see you in the next one.